I designed my first PCB. I was really intimidated before. I had no idea if it was going to work, and it did, and it was amazing. It was the most exciting thing to see this creation come to life and do the very boring job of changing the brightness on my monitors. This was largely in part to KiCad, which is a free and open source piece of software, which you probably already know because you're here watching this talk. These two people here know more than anything how important KiCad is to the open source community. So this is Supressor and Clement. They both, in their free time and possibly for jobs as well, hack on hardware for fun and profit. And they're going to talk to us about some of the cool add-ons that can make KiCad even more enjoyable to use. So please give them a big hand.
Right, hello everyone. Welcome to our talk. So we're here to tell you about the ecosystem of tools that people have built around KiCad. So KiCad is awesome. We all agree about that. If you don't know what KiCad is, I'm very surprised you're here, but it's a really nice tool for making circuit boards. And it's awesome, and some people have made it even more awesome. But sadly, a lot of people who use it have no idea that there's all these wonderful extra tools that are not part of KiCad, but that you can use with it. So we're here to do a bit of show and tell and get you excited about it and hopefully make your life as much easier as these tools have for us. So first of all, there's this thing called the plugin and content manager in KiCad. And it's possible you're not aware that this is a thing, because when the first version that had it was released, it was a bit hidden, like literally not visible in the main window, but that's been fixed now, so update your KiCad, it will be there. And many of the things that we're going to show you are on there, and there's also many other cool plugins that people have built. So go there and check it out. It's got a lot of good stuff. Right, over to you.
All right, so I'm going to start to show you KiBuzzard, which makes pretty labels. It's in the plugin and content manager we just had. So we prepared a little demo on how that looks. So usually when you have your board and you want to add some text to explain what's happening, you use the text tool, place it somewhere, and you have the boring text with the boring font. But you can do nice labels with this add-on. So I just pressed the button on the top right, see that again, like over here, open that. You can put in your text, you can specify how it looks, so I'm changing the corner style here, and yeah, we have our label. Just place it, as simple as that, and do more of them. And those are really nice. We are going to see them in the 3D view in a moment, over there. And that is exactly how they will look on the finished board. So this is pretty nice. The next one I'm going to show you is the interactive HTML BOM. So the BOM is the bill of materials. You use that to order parts, but also when you assemble the board to see which parts go where, which you have already placed, and so on. And this thing, as it says, is interactive. So I'm going to show how it looks. We are going to start with this is our finished board in a 3D view. We want to assemble that. This is it in the PCB view. And what you need to do is figure out which part it is that goes there. So you can open up that part, see what it is, pick it, and place it. But that's pretty tedious to do. So we are generating that BOM and opening that up in our browser. So it's just one HTML file that contains everything. And there you have a PCB view that is linked with the BOM table. As you can see, when I hover over that table, it highlights the parts that are on the PCB, so I can see what they are. It goes both directions, so I can place the same values pretty easily. And then there's also on the left side of the table, there's those checkboxes you can use to track which parts you already sourced or put in your parts bin, and which parts are already on your board. And that is actually configurable, so you can add more rows of that for other checkboxes, like I ordered that part, I put it in the right place, I prepared it for assembly, I put it on the board, and so on. You can also configure if stuff should get grouped or so on, so there's lots of options to that. I figure them out for yourself, I guess. Yeah, that's it for the interactive HTML BOM. I really like that. You can also use that on a tablet computer, for example. I just put that, it's just an HTML file, put it on your workbench, press things, and be done.
There we go. Now you're in camera.
Okay,
Yep.
so that was, I think, our second tool. So up for our third tool, which is called KiCad. That one is used to make panels of PCB. So if you have a single PCB, but want to have a panel of them, that automates that stuff. So you don't have to draw your panel manually, as you would have done in earlier, before this tool didn't exist. So here's a quick demo of that. So we start with our single PCB. It's a rectangle one, a pretty simple one. We need to actually make a new file for this tool to work, then open up the tool, select which board we want to panelize. On the left side, we have all those settings in a nice graphical user interface. On the bottom, there's those settings as JSON representation. And on the top, you have that if you want to run it from the command line. So you can do that tool interactively and on the command line. So just hit panelize, and there's our panel. Going to show that in the 3D view. Take some time on that machine. And this is how it looks. So we have a panel with some tabs and mouse bytes in it. But there are some parts missing because I put in the wrong settings. So we're going to change those. Going to change the spacing between the PCBs a little bit. And also change the way how the tool scans for which parts go on the panel. And hit panelize again. It replaces what we already had. We get a new panel, and you can probably see that there are some more connectors on it once the GL player decides it wants to work. Here we are. So there are now a few more parts on there. And this is our finished panel. You can configure also not this type of panel routing. You can also include V-scoring, add tooling holes, fiducials, and everything that's required for proper PCB assembly. So there's lots of options to that tool. It has a great documentation. So one of the best documented tools I actually know. So look into there to see what it can do. Next is also KiCad. It's the step after that. So when we have our panel, we want to generate production data. So export Gerber files. You can do that manually in KiCad, but you can also automate that. And good reason for automating that is making less mistakes. And also you can have presets for different manufacturers, because there's different ways on how those Gerber files should be called, and there's naming conventions. And there you can script that. So on the command line, call KiCad. I put in the fab PCB way, that's a preset that is in there. And then we look into the out directory, and there are our Gerber files already. As simple as that. And we can view them, and then we will see that there is the panel of our Gerber files. This is the panel we had earlier exported with the correct settings to order them on PCB way. There are presets for a few different manufacturers, but you can also do your own and reuse them every time you make a board. So we talked a lot about boards now. So another tool we need is one for generating footprints. So quite a lot of footprints are tedious to make manually because they had a lot of pins. We have an example here. This thing has 42 pins. Placing them all one by one is definitely not something one would do, so let's automate that. To do that, we need to look at the mechanical drawing and figure out where those things are and where they go. So we check the other page of the data sheet where we have all the measurements and how big the part is, how big the landing pads are, and so on. And then we punch them into a YAML file. So I prepared that, so there's already the finished YAML file, so you see that there are a lot of numbers in that file that are basically the same that are in the data sheet. I think all the things are pretty self-explanatory, but there's also great documentation for this generator. So what we do next, we just run it. It says it's building the footprint, it has generated that one, and now we can open it up in the footprint editor. And that's it, there's our generated footprint. Actually typing in all those numbers took me like a few minutes. But now comes the interesting part. If you want to make variations of that, you can just copy paste it, edit it. And what I'm going to show next is we're going to change the amount of wires in there as an example. So I go over here, remove one setting for the wires, enable another one, save that, run the generator again, and then we're going to have a look at the changed output of the generator. That one should have only 3 wires, like so. And if you look at that in the 3D view, we can also see that the paste, which is the gray part, doesn't overlap the wires, so we probably have less paste leakage when soldering, so it's most likely a better footprint. This generator can not only do these types of footprints that I just shown, so this is a QFN footprint, can do various other types of packages, as long as they are reasonably sane. So there are quite a lot of packages out there that have not a regular pin spacing and simple odd pad shapes. The generator cannot do that, but you can probably like do half the work with the generator and then edit the rest of the stuff manually. Next tool is actually not directly related to PCBs, but to your whole assembly. Because what you need to do in most cases is actually not have a PCB, but also connect it up to lots of other things. So you need wires. And it's nice to document them, and you can do that with WireWiz. And in a similar way that we've seen with the footprint generator, you can type in how your wiring harness should look like. So in this example, we have 2 connectors at the top. Then we define 1 cable between those connectors. And the third block at the bottom is how those are connected. We run that through the generator and get a visualization like this. I have another example for that that looks a little bit more fancier, has more colors, more pins. You can do that with multiple connectors, so it's not just limited to 2 on each end. So there's basically no limits on how complicated your cable should look like. You can also include pictures in there for documentation of how the plug looks, add more text, and so on. This tool also has a pretty nice documentation. There's lots of examples you can look up for inspiration. I totally recommend using that. Yeah, and now I think it's time for Clement to show you a few other tools.
Oh, right. So the next tool we're going to look at is KiCad Step Up. And this is an enormously complex piece of software which does horrible things behind the scenes to make your life easier. So it is a plugin for FreeCAD. And FreeCAD is a parametric 3D graphics, 3D modeling editor for solid modeling and solid CAD. And what KiCad Step-Up does is it can read and write KiCad files of all currently usable versions, which is a ridiculous maintenance effort, but it's amazing that it exists because you can do really cool things with it. So we're going to take a footprint that was just generated and make a 3D model for it. So we have this footprint, but it has no 3D model. And this is the case for many footprints in the KiCad library and all footprints that you've just freshly generated yourself. So we're going to import that into KiCad using KiCad step-up mode. So we're going to load the footprint. And I'm loading the PCB here. This is a mistake. It should be the footprint, but in this case, it just does the right thing. Yeah, so this is our footprint. And we're going to then design a model on top of it. And this is now the standard FreeCAD design process, which is like where we're building basically a sketch and then extruding that sketch. So I'm making a rectangle here, and you then look on the datasheet and check those dimensions and enter those in here. So this one is supposed to be 4. And then the height of it is supposed to be 1, so we're going to extrude it to 1 millimeter. And then we're going to add a pin 1 indicator in the top left. So that's the orientation that the footprint was in KiCad. And then we can use the edges we just added as a reference and mark the distances from the edge. Yeah, and then the size of that circle, which is usually not specified, but you can also do it by eye. Yeah, and then we're going to change the color. And the really nice thing about using FreeCAD for this kind of work is that you can actually get a screenshot from your datasheet and insert it as an image plane and have that in the background and kind of make your 3D model match. So even if the dimensions on the drawing are not really well documented, you can still kind of fudge them into the right place and get the model that's good enough for mechanical testing. So I'm exporting this as a step file now. And then on the KiCad side, I go in there and add a 3D model. So I find that file. And then we have a 3D model on our board. Yeah, so that's one of many, many things you can do with KiCad Step Up. I'll show you 2 more. So we're going to take a board, which is just a really boring rectangle. And we want to make it fit around the common household object at hacker camps, which is this mate bottle, which is slightly incorrectly measured. I do have a data sheet for a mate bottle, but I was too lazy to type in all the correct dimensions. So we're going to import our board using the load board function. And it's going to complain that it's missing some parts, but that's fine. Right, and then we're going to take this bottle and copy it and paste it into that file. And then we're going to change its position to get it where we want it to be. So what we want to do here is make a board that is much nicer shaped and that then fits around the bottle without any additional support. So we're going to place the bottle in the board where it's supposed to go. And then we're going to change the shape of the board. So I'm hiding the board itself and showing just its outline, which is also imported from the KiCad file. And I'm going to delete that because I don't need it anymore. But I know where the parts on it are. Like I can still see the circuits that are on there. Now I'm just going to use the arc tool to make some nice looking shapes. And drawing this kind of shape in KiCad is possible, but extremely painful. So it's not something you really want to be doing. And in FreeCAD, it's really, really easy. So I'm using the tangent tool to now align all the curves so they all line up. And then I can drag them around to make them have the shape that I imagined for this. And like this board only has 1 part on it. If you have a bunch of parts on it, you can also see like, okay, we cannot move things around there because then there won't be enough space for the parts and things like that. So now we're adding a cutout for the bottle. Now this is a 2D view, but we can actually rotate it in 3D and use that to adjust just that to make it fit exactly that spot on the bottle. So then we can now take this and then push that sketch to a PCB. And this will actually overwrite our KiCad file with the new shape. So then over here, we need to actually close this file and open it again, because it's now being edited outside of KiCad. And now we can remove the old outline, and we have this one. So yeah, that's how that works. And I'll show you another thing. This is actually more like a FreeCAD feature in itself. And this is, we're going to take a board and fold it. And you might be wondering why you want to fold a PCB. But there is a thing called flexible PCBs, so you can actually make PCBs that bend. And it's very hard to actually check whether those are correct without actually bending them. So before discovering this tool, I would just print them out on paper and bend them. But it can now be done in CAD. So FreeCAD has this tool called Sheet Metal Workbench. And with that, you can take a board. So this is a board also imported the same way. So I've hidden the board and just have the outline. And I've added a line to it, and I can bend around that line. And you can put in a bunch of bends and like make it go any direction, any angle, any turn radius. So this, for example, is this is just a simple PCB cable made to fit between two parts of a very small device. So this is how you verify that it actually fits. So another tool. This is a KiCad plugin, Code Replicate Layout, and it is there to save your time and effort when you're doing a lot of the same thing. So, for example, we have a complex design here with a lot of hierarchical sheets. Each one has an HDMI connector, which has a bunch of high-speed connections and some ESD diodes. And I've painstakingly done the routing for the exit from the connector in here. And I don't want to do it 8 more times. So what I do, I select the connector and go to Replicate Layout. And it finds all the sheets in the schematic that match this one. And I can select any number of them. And then go Replicate Layout. And it will place the parts and connect them in exactly the same way. And this saves such an enormous amount of effort. So yeah, don't repeat yourself. Make the computer do it. Right. Over to you for the next one.
Yes. So the next one is called PCB Checklist. It's actually not really a tool. It's just a list somebody made with a list of all the different types of mistakes you can make when designing a circuit board. So what you can do is go through the list and make sure you don't repeat them. I think all mistakes I had on circuit boards so far on my own were actually already on that list. If I just had followed that list, I would not have made them. Here's an example of just the top of the schematic review checklist. I didn't count how many points are in there, but this is perhaps like a fifth of the complete list, perhaps less. There's one for schematic review and one for PCB review. I highly recommend you check this one out, and if you find something that's not on the list, then open a pull request and ask to add it to that one. And that brings us to the last tool, Git. So KiCad was designed to have its projects tracked in Git. So there's actually a lot of design and engineering work in the file format, so it produces nice diffs when using Git. For example, most files have a stable sorting. There's a few things that don't work too well right now, but it's really good, I would say. So if you change just a few items like text, move one part around or so, you can actually read that in the diff and see what has happened. So I highly recommend you manage all your KiCad projects in Git. And that already brings us to the end of the tools we wanted to show you today. We have one more slide with all the URLs to all the tools we showed you today. We are also going to upload those slides in pre-talks, so you can look them up over there and follow those links. And yeah, this was just like a small introduction. So we selected those tools that are the easiest to show and that bring the most value to like the average user, but there are quite a few more. So just search around. There's, for example, the KiCad IRC channel, or there's a KiCad forum, and lots of people hang around that have created lots of more different tools and workflows for KiCad. So, thank you. I think we're ready to accept some questions.
Thank you very much, both. If anyone has any questions, there are 2 audience microphones in the center aisle, so please wander up to there and ask them.
Hello, my name is Axel Roest. I have a question about the interactive HTML bomb. It seems to be like a tool that you use over several days while you're managing stuff. Does it store the status of the checkboxes anywhere in a cookie or somewhere? Or do you have to do it all again?
Yes. It does store the state, I think, in the local storage of your browser. So in the demo that I showed, you probably seen that a few of those boxes were already checked when I opened that thing up in Chromium. That's because I recorded that twice because I made a mistake the first time. But the state was saved.
Cool, thank you.
Hi. So in the same example in the HTML thing, you had some LEDs lined up around some shape. Do you have an extension for that and a plugin, or did you do that manually?
Okay, there's actually also an action plugin in the plugin and content manager that helps you to distribute parts around the board, also in, like, for example, polar coordinates or rectangular. In that specific case, it follows a rather complex Bezier curve outline. So what I did is I planned it up in mechanical CAD, exported those layers into KiCad, and manually moved the LEDs to the exact position. It's only 32, so it was doable.
Yeah, you can of course write a script to do it because there's a Python API for KiCad.
Yeah. If it would be like more than 32, I would probably have scripted that.
Okay, if there are no more questions, that brings us to a close. Go forth and use your new KiCad abilities for good, or at least morally dubious purposes. Oh, there's another. Hello.
Yes. So if people don't have you folks to point them out to these kinds of things, what can we do to KiCad to make all these things more obvious?
Not hide the plugin and content manager.
Okay.
You can also join the documentation team. So KiCad is, like, the project is always looking for people to help. And for example, if you open the current menu, there are actually quite a few spots where it says, like, kind of to do, document this, write down how it's going to be used. Any help there is welcome.
Okay. Oh, that's it for the stage for the rest of the evening. So thank you very much for coming, and thank you, Clemens and C. Presser.